Using your calculator, and choose R, that's at CNR, that's on your calculator. So if I go under probability, so math, and then probability, you see NPR and you see NCR. NCR is what you're going to be interested in. Now, I don't know where I have my calculator set mode-wise, so if I press 3, I do not know what I'm going to get. Yeah, this is set in classic mode. So if I wanted to do 15, choose 5, I would put in 15, and then math, probability, CNR, 5. Now that works the same way on this guy. If what you have is this one, you're going to go under probability, you're going to go to CNR. See, there's factorial. So I'm going to go back out to the home screen. See if I can get out of here. And so I want 15, choose 5. So 15, probability, CNR. So now 15 is N, R is 5. Press enter, and you should come up with hopefully 3003. And yeah, there we did, 3003. So it works absolutely the same on this calculator too, as it does in classic mode on the graphers. Now, if I change my mode into math print, it's much nicer. So for those of you who have math print on your calculator. And what the difference is when I do math probability, and I do CNR, it comes up actually as it stands. So I can just now put in 15, enter, jumps, whoops, nope. And then I need to hit the right arrows. What I need to hit is 5, and then you'll come up with 3003. So either way, but if I'm using classic mode, or your calculator only operates in classic mode, you need to put in N first, then hit NCR, and then put the other number in, and it will come out the same way as you do on this one. So you don't have to have a grapher in order to be able to do this stuff. It works quite nicely. So this is 3003, and if I want 20, choose 15. Now, if with my particular history toast calculator, and so most of you can do this, you can go up and you can pick that off. Just use the up arrow. When I hit enter, now all I need to do is change that to 20 and 15, and it's going to come to 15,504. Now for those of you with this guy, and he's not too well backlit was the problem with this, oh, there we go. I can press the up arrow, and it brings that formula back. So it has a stack just like the color calculators do. And then you can just change the, that from 15 to 20. And then change that from 5 to 15. And you can come out with it. So that works quite well. Just hit the up arrow, and that allows you to move up the stack, pull off that formula, and be able to input it. But the big thing is that you can do it either way if worst comes to worst. Now, where in the world are you going to use this? Well, one of the things is in this particular instance, this happens to be a polynomial expansion of a plus b to the n. It is a coefficient, c, times a to the n, b to the 0. Notice, n plus 0 is n. You're always going to add up to whatever number power you're being raised to. Then a coefficient, and it's going to be a drops by 1, n minus 1, b increases by 1. Again, if you add n minus 1 and 1, you add to n. Then a number, a coefficient, and n drops by 2, b goes up to 2. So a goes down, b goes up, till you get all the way to the end is you're going to have a coefficient. A is going to be to the 0 power, b, this is an n. B is going to be to the n power. 0 plus n is n, which is this right here. What these c's are, these c sub k's, are the coefficients. It can be gotten in one of two ways. One is Pascal's triangle. And so if I take a look at the coefficients, what would the coefficient be? This would be the same thing as the coefficients of a plus b to the 0 power. Well, that's just 1. A plus b to the 1 power is just a plus b. Coefficients of a and b are just 1. A plus b squared is a squared plus 2ab plus b squared. And notice, 1, 2, 1. The coefficients of a and b. A goes down, b goes up. But those are the multipliers. Those are those c's. Oh, sorry about that. Those are those c's. Now, a plus b cubed is a cubed plus 3. A goes down 1, b comes up 1, plus 3. A goes down 1, b comes up 1. One, 3, 3, 1. 1, 3, 3, 1. They're called the binomial coefficients. Binomial coefficients. So if I wanted to expand a plus b to the 4th, it would be 1a to the 4th plus 4, a goes down, b comes up, plus 6, a goes down, b comes up, plus 4, a goes down, b comes up, plus b to the 4th. They're called binomial coefficients. And Pascal's triangle, and I use Pascal's triangle all the time, Pascal's triangle can give you those coefficients. So if I wanted to use Pascal's triangle to do x plus 3 to the 5th power, well, what would it be? 5th power is this row right here. So it's 1, and in this case, by the way, a is x and b is 3. So it is 1, and the highest power, remember they have to add, we start out with x to the 5th power. So it's 1 times x to the 5th. Plus 5, x to the 4th times 3 to the 1, plus 10, x to the 3 times 3 squared. A goes down, b comes up, plus 10, x to the 4 times 3 to the x to the, I'm going down, x to the 2, and the question is, how did I know? I should be able to add these exponents, and they're going to add the 5 each time. 2 plus 3, 5. 3 plus 2, 5. 4 plus 1, 5. What's actually here, which you don't see, is 3 to the 0 power. 5 plus 0 is 5. Plus 5, x goes down, 3 goes up, plus 1, x goes down, 3 goes up. So this becomes x to the 5th plus 3 times 5, 15, x to the 4th, plus 9 times 10, 90, x cubed, plus 10 times 27 is 270, x squared, plus x to the 4th is 81, so 81 times 5 is 405. X to the 1 plus 3 to the 5th is 243. It's using Pascal's triangle. Use Pascal's triangle and patterns to expand. We're now going to the 4th power. In this case, A is 3x and B is negative 2. So I'm looking at this as being 3x plus minus 2 to the 4th. Using Pascal's triangle, the 4th row is to 4th power. So it is going to be 1 times 3x to the 4th, negative 2 to the 0. These two powers should add up to 4. Plus 4 times 3x cubed times minus 2 to the 1. Plus 6 times 3x squared times negative 2 squared, plus 4 times 3x to the 1, negative 2 cubed, plus 1 times 3x to the 0, negative 2 to the 4th. 3x to the 4th is 81, x to the 4th, times 2 to the 0 is just 1, so that's okay. Now, I need to be very careful here, and I need my white tape, and I'm going to say, well, why? I've got an alternating one occurring, so this is not really plus. Because anytime I raise negative 2 to an odd power, it is going to be what? Negative. So this is going to be 4 times 3 cubed times negative 2. So 4 times 3 cubed times negative 2 is going to give me negative 216 x cubed. Now, negative 2 is being squared, so it's going to be plus 6 times 9 times 4 is 216 x squared. Now, negative 2 is cubed, so that's going to be a minus 4 times 3 times negative 8, It's going to be 96. And that's to the fourth power, and this is 1. So that's going to be a plus to the fourth, which is 16. Pascal's triangle. And in a sense, if you're going to expand up to x plus y to the fifth, it's almost the easier way to do it. Hate to say that, but it's true.